In this video, we are going to look at alignments and profiles to determine the next steps of our design here. So I'm going to use the file that I started with points and surfaces and that we tweaked. And remember, this is a massive area. If I measure the total height of the surface, it's about 8.5 kilometers by 8.5 kilometers. So we're not going to do an alignment or profile that nearly that long. We'll just do a little chunk so we can highlight the way to make an alignment, how to modify an alignment. We'll look at some curve options for alignments, and then we'll create a profile with some curves in that as well. So again, this is the file from the previous video tutorial that we did, and let's zoom in and get going. I'm going to turn on my air photo just so I can see what's underneath. And again, this is part of Calgary. Let's just put a new road across the entire city somewhere. And we'll bulldoze some houses, which generally you don't want to do. So I'm going to start by drawing a polyline, and then I'll turn the air photo off just so it's a little bit faster. So polyline, and I'm going to shut my grips off, or my O-snaps. O-snaps on an existing ground surface, especially made out of LiDAR data, is very, very, very slow. It could slow things down a lot. I'm just going to click over here somewhere, and I'm going to start drawing. I'll build a new road here, and then I want at least one corner. Let's cross this gap, and maybe work our way up here. So even though I said it wouldn't be that long, it is, I guess, quite a long road. However, that's okay. So I tend to draw this with a polyline before I turn it into alignment. There are ways of creating alignments by layout. However, I find it easier just to start with your polyline. You can sketch it in. It's easy enough to tweak and move and adjust if you have to before you turn it into alignment. So either way is perfectly acceptable. So either create from polyline or create by layout. I just prefer the polyline way. So I'm going to then go alignment, create alignment from polyline. Then Civil 3D asks you to select your first line or arc or polyline. I'm going to select on the left hand side here and hit enter. Then Civil 3D asks me press enter to accept the alignment direction. So I drew this left to right. Just because you drew it left to right does not mean your arrow will be pointing to the right. I don't know what causes Civil 3D to display that backwards for some people. However, just pay attention. In this case, my alignment is pointing to the right. This becomes incredibly important when you are going to read drawings left to right or bottom to top if we have to rotate it. So in this case, left to right, I'm going to accept it, hit enter. If it's wrong, you can hit reverse, but hit enter. Then I'm going to name this. We'll say we're putting in Highway 50. That's the name of this one. It's a centerline alignment. Design criteria. This is where we're going to set up our design speed. Now, design speed is not the same as posted speed. So what you see on the highway would be, say, 100 kilometers an hour. We would actually design that for 120 or 130 kilometers an hour. So I'm going to change this to 120 kilometers an hour. I'm not going to select these because these are based on American information, so US data, where we're in Canada and our standards are different. And I don't want Civil 3D telling me something is wrong when in theory it is not. We could change the starting station if we had multiple roads. We could set this to 15 plus 0, 0, 0. However, we only have the one road, so 1 plus 0, 0, or sorry, 0 plus 0, 0, 0, we'll set that for. I don't ever put alignments on sites in this case because the sites interfere with grading if you have objects near it and you could wind up with some issues. We only have one road. The sites aspect is more if you're doing a subdivision and wanted to break up land into different parcels. We'll choose the alignment centerline style. It's going to make a layer for us. We'll choose our label set. Let's do them perpendicular. Now add curves between tangents. If this is selected, it will make some simple curves, similar to just filleting these two lines together. Now, when we are designing a highway, that is not acceptable at all. We cannot have simple curves. We have to have curves that are safer. I tend to leave this off, and I'll just put the curves in myself. And erase existing entities, it just gets rid of the underlying polyline. So I'm going to hit OK. and let Civil 3D update this. So now that it has, we do have an alignment. It starts over here at 0 and it ends over here at 9691. So 9.6 kilometers long, this piece of this alignment here. So now when we're going to design the roads or the curves, we need to know some information. So we have the design speed. It's 120 kilometers an hour. The posted limit will be 100, but we'll design for 120. So we need to go to the province of Alberta, Alberta Infrastructure Highway Geometric Design Guide. This is chapter B, and we're on page B29, which gives us our curve radius super elevation table. So we need some information from this table in order to design our curves. Now, being that we have a design speed, and again, pay attention to design speed, don't pick from the 100 column. You want to pick from the 120 column because we have that alignment set to 120 kilometers an hour. The minimum radius here that we can have for a corner is 750 meters. Now this is to help keep cars on the road. We don't want to curve tighter than this because cars will drive off the edge. And I also don't like to design anywhere near minimums. So usually pick a few up and design, say, around the 1,000 meter curve here. And the bigger the better. However, at some point it's just not feasible to have a 10 kilometer radius, a 10,000 meter radius. In this case, we don't need to worry about any spiral curves. We could have a simple curve in this case because the radius is so big you won't even really notice it. However, let's go about 1,500 meters, a 1,500 meter radius. So we'll remember 1,500 and we'll remember this A value of 315. So I'm going to minimize that and go back to Civil 3D. So 1,500 and 315. So once we're back in Civil 3D, we can close this Create Points dialog box if it's still open from the previous exercise and select our alignment, not the labels. We'll zoom in and select the alignment. I'm going to right click and I'm going to edit my alignment geometry, which brings up the geometry editor for your alignment itself. And you could set curve and spiral settings, so as you drew it, it came out with curves and spirals, or just tangent to tangent, no curves, tangent with curves. Again, this is more under the alignment create by layout. The second button here, we can insert a PI, so if we wanted to add another corner somewhere, we could do that. We could delete a PI. We could break apart a PI, so have a break in our alignment. Again, most of these commands we won't be utilizing, but we could add we could make our alignment longer right from within this window. We can add curves, fillet curves, fixed curves, free curves, etc. Floating lines and spirals. But however, we want to use this button here and create a free spiral curve spiral between two entities. So we want a spiral curve spiral. It kind of gets you into the corner, helps you turn right a bit. Then you have the main curve, then it gets you out of the corner and it's almost natural. So I want a free spiral curve spiral between two entities. Now Civil 3D asks you to select the first entity. This is where the direction of your alignment matters. We have 0 over here, so we'll be driving down the road this way, and then we'll turn onto this one. So I'm going to drive from here to here. Then Civil 3D asks you, is the curve solution greater than 180 or less than 180? We'll go less. Our radius of curvature was 1,500 meters. Our spiral in length, we don't have the length, but if we flip back to this table, this is the design A value. So we look at A value here. And A is 315. So always make sure to hit A. Our spiral in A value is 315. Our spiral A value out is the exact same 315. So I'm going to type those two in and I'm going to hit enter twice to exit the command. And then I'm going to go into the alignment style and change just a couple things here. Lines will leave cyan, the curve will make blue, and the spiral we will make yellow. So we can see the difference between them. And I'll hit OK. So we have our tangent line here, straight section. Then we have a short little spiral where our transitions will take place to the main curve, to a short transition out, back to a tangent. So we can go and do the rest of these corners, and let's pick a different line from this table for that. We'll do 1700 and 340 if it allows us. So I'll go back, spiral curve spiral from here to here. Oop, from here to there. Less than 180, 1700, 340, and it's already defaulted to the A value, 340. And that one has allowed us to do it. Let's do this one the same, from here to here. Oop. One or more, okay, we'll do it from here to here. Be careful when you're clicking, it doesn't really tell you what you clicked on. Less than 180, 1700, 340, 340. So we have our three corners in, and they all have the spiral curve spiral. That is the way that Alberta Transportation wants things to be designed. Now, when we're choosing which kind of curve to use, the angle matters. If we have a road with a tight corner, that would be different than a road with a shallow corner. The shallower the corner, the bigger the radius you should use. So I'm just going to use a simple curve to highlight this. If we fillet these two lines together with, say, from there to there. Okay, let's explode this into lines. Let's fillet from here to here. Oh, I have to select the radius first, sorry. Fillet radius, we'll say a radius of 500 from here to here. That's our corner for that. If we do the exact same fillet here, it's not worth putting a 500 meter radius in here. So that's just not feasible. We're going to be driving straight and immediately have a tiny corner to turn right, and people are not expecting that. So if we go a fillet radius of 1,000, or we'll do 2,000 now. We'll do that, and we'll do 2,000 here. And I'm leaving those previous arcs there so we can see what happens. The 2,000, again, it's a bigger corner, but it doesn't change by that much. This is only about a meter difference in that angle. So let's try fillet radius 10,000. Let's do that 10 kilometer curve. It's not going to work on this line because that curve is going to be way down here to way up here maybe. However, on this line, we now have a 10 kilometer radius. Now that doesn't seem that much, but you have just made this road safer because you have given it a bigger curve where there is only 5.8 meters difference between your original curve and your final curve. So the shallower the angle, I say the bigger the radius. Now we could go much bigger than 10,000. You can go 20,000, 30,000 on little angles like this, and it's not going to make a huge deal. But on tighter curves, like the one on the right, it does make a big deal. So let's change that to 5,000. If we can put a 5,000 meter curve in here. So we can. Now if we measure the distance from them, we need, that's about 670 meters from here to here difference in the angles. So the shallower the curve, so this will be a shallower curve, the bigger the radius, the tighter or the bigger or the less angle between it, the smaller the radius. However, we don't want to go super small down to minimums. So that's just a bit of thinking, a bit of critical thinking to get those put in, and just try and stay above minimums for these. So let's turn this into a profile. So we're going to go profiles, create profile from surface. We only have one alignment. We only have one existing ground. I'm going to add it in. The style should be existing ground. We'll hit OK. I'm going to draw in profile view. I will name this the same, Highway 50. I'll just name it Highway 50, not alignment. And because this is 10 kilometers long, I'm going to do 10 times vertical 100 meter station interval. And we'll hit next. We're not going to change any of this stuff, but you could set up automatic stations to view different things. You can set up automatic or user specified elevations, display options, if we have data bands to show a difference between existing design, and then finally hatching, but we're not going to turn any of that on. We're going to hit create profile view and we'll click. So going from left to right, this profile starts on the left at 0 to the 9,600-ish on 9,300 on the right. And we see that we're higher over here than we are over there, which makes sense because the elevation banding from the previous example. So I'm going to close my alignment layout tools. Or before I do that, let's take a look at one thing. Once you have your spirals in, I would select this button here, this grid view, and it displays all the information about your alignment. So we have our spirals here, 1500, 315, 1700, 340. You can come in here and change these to different numbers and your alignment will update. So let's go 3000 and 450. Let's change the last one to 3000, which makes that curve a lot bigger, and 450, which made the curve bigger. So we have a curve, a short, tiny little straight section, then back into our curve again. So you can come in here and change things. Make sure the A value is not inadvertently typed under the length. So we'll close that now, and we'll close that. And our profile has adjusted. It's now 9,183. So we shaved 200 meters off that road. Under profile, we're going to just sketch in a design ground quickly and try and follow this the best we can. We're going to create a profile by layout, and Civil 3D asks us to select the profile view. I'm going to select this green boundary. I'm going to name this Highway 50 Design. My style is design ground. My design criteria, we're not going to select this because, again, it's based on American standards, and they don't conform to the Canadian ones. They don't match the Canadian ones. So we'll hit OK. Under the first drop-down, I want to go into draw tangents with curves. However, I want to look at my curve settings first. We use what's called a K value. And at 120 kilometers an hour, I'm not sure if it's 130 and 70, but we can go back to that design guide and take a look. And I'm going to find the page and I'll be right back. Okay, back to that document. It's still in chapter B and it's on page B49. So we'll see 120 kilometers an hour. We have a stopping sight distance of 130, a passing sight distance of 685, headlight control for, that was crest curves, sag curves, headlight control of 70, and a comfort of 35. So we're going to go with the 130 vertical crest curve and 70 vertical sag curve numbers. The curves become much larger if you try and meet the passing sight distance, so that's why you do not see many passing lanes on mountains and in hills and on corners. So crest 130, sag 70. Those are already in this drawing for me. So I'm going to draw tangents with curves. Now when I start drawing this, I'm going to attempt to approximate 50% above the existing ground, 50% below the existing ground. I'm going to try and trace this almost, but I'm not going to click a million times. I will also turn off my polar tracking. So my road, my first click is probably going to be about right there. And then I'm going to go down the hill and we might go down to there. And then we'll go off to the right and we'll keep tracing down. Again, I'm just trying to go 50% above, 50% below. We'll go about here. And then do I want to come up this hill and go back down, or does it make more sense to maybe have this hill pushed to fill this hole? So trying to think about dirt volumes at this point as well, I might just go straight through that hill like that. And then we can go down the steeper hill. And yes, this is a very poor surface because it is the very high density or low density LiDAR. So we'll try and do our best. In our design, we have a much better definition for a surface, so this is easier. And also we're not doing 9 kilometers long. So again, I tried to trace it 50%. We'll build a bridge over this big hole here if we have to, but my design line is about 50% above, 50% below. This triangle is where I clicked. However, Civil 3D has put these curves in for us. Now, if you didn't set those settings up and you only drew tangents, I'm going to delete one of these curves. And to show you that we can draw free or fixed vertical curve parabola. So I want to go from here to here with a K value of, and it's 130 from my specifications. So there's our vertical curve if you failed to put it in. And we can adjust these. They have the same rough commands that, roughly the same commands that the alignments have. You can add vertical curves. You can add extra tangents if you forgot some. You can copy a profile, change just random things. You can delete pieces if you have to. And finally, this grid view is the same to check all our K values. So again, that was drawing an alignment, drawing a profile. There's many labels we could put on this. And I'll just show you a couple where they are. If we go into edit alignment geometry, edit alignment labels. Let's add in geometry points to see those. And we'll just add them all. Again, pay attention right now to what you're doing. And we'll do, we don't have any super elevation, so that's not gonna, we'll just do geometry points and I'll hit OK. And it's updated tangent to spiral, spiral to curve, the midpoint of the curve, curve to spiral, spiral to tangent. So it's added those labels in, which work along with our super elevation. Your profile is the same, edit profile labels or edit labels. We want to add in, say, horizontal geometry points, so we could tell what's on the alignment and related to the profile. I just cancel that. We can add in lines, which is your grades. You can add in crest curves and sag curves, and I'll just hit OK to show these labels. So this is 0.16%. This curve, here's the information, a K value of 130. There's a length, a station, elevation, another grade, another crest or a sag label here, crest label, sag label. So labeling profiles, giving the information that we need.